welcome to another MedCram COVID-19 update. It's been a little while because I've been in the intensive care unit treating COVID patients. Sorry to say that we are starting to expand a little bit in Southern California, and we are seeing more patients now in the intensive care unit with COVID-19. If we look at daily new cases in the United States, they are certainly on the uptick here. And whereas we had not seen an increase in the new daily death rate in the United States, it is now starting to increase. So where I work, which is in San Bernardino County, which is in Southern California, since the beginning of the pandemic, what's happened to hospitalizations, you can see here, the green graph is the confirmed COVID-19 positive patient representation, and the pink here on top are those that are suspected. You can see overall that hospitalizations here in Southern California are on the rise, and that is not unique. In terms of the United States, we're starting to see daily new cases in South Dakota start to reach all-time highs, and the death rate is also going along with that as well. We're also seeing that in North Dakota as well in terms of daily new cases, and also the daily death rate as well. But perhaps the epicenter here in the United States would be the state of Texas, where we can see that daily new cases in Texas has reached an all-time high, but daily deaths have not yet increased. That could be because of a time lag. Of course, this is not just the United States, but it's going up around the world. We see daily new cases increasing here and are at an all-time high. And daily deaths around the world are also at an all-time high. As an example, daily cases in the United Kingdom are quite elevated. And whereas before we did not see deaths increasing, we're starting to see daily death rates increase in the United Kingdom. In Italy, we are again seeing an increase in the daily new cases. And this is reminiscent of what we saw in March in northern Italy, where we were seeing an increase in daily deaths as well at this point. And this is all to say that, of course, there's a lot of bad news around the world regarding this virus. And, of course, recently there's been some good news, and we're going to talk about vaccines. And a great website to follow this is RAPS, or Regulatory Affairs Professional Society, which has a great COVID-19 vaccine tracker. And for the next couple of videos, we're going to highlight different vaccines that are being developed around the world for COVID-19. In the next few months or even weeks, there's going to be vaccines that are going to be released, brought to market, and consumers are going to have to make a choice as to which vaccine they want to get. It's going to be really important to understand and know about those vaccines and their track records. So we're going to dig deep and look at these vaccines and compare them looking at various characteristics, safety data, and efficacy. And the first one that we're going to look at is the vaccine that is being put out by Pfizer and BioNTech. And you can see here on the COVID-19 vaccine tracker, there are a number of different vaccines that you can click on them, and there are links so that you can look at the different publications and be educated on these vaccines. So the first one that we're going to look at is the Pfizer-BioNTech one that is here, and let's get started. So the first thing that you've got to understand is the biochemistry of what's happening with an infection. Now, as we've talked about before, you have a cell, and on that cell is a ACE2 receptor. And then what you have is the virus, and on the virus, as you've heard by now, are spike proteins. And so what happens is this spike protein interacts with this ACE2 receptor, and the virus gets internalized into the cell, and it basically takes over the cell or hijacks the machinery of the cell. And so really, this interaction between the spike protein and this ACE2 receptor needs to be blocked if you want to prevent infection. And one of the ways of doing that, traditionally, is by injecting fragments of the protein into the body and have antibodies be made against these spike proteins, so that the virus is not allowed to bind this ACE2 receptor and you neutralize this infection. And that's generally how vaccines have worked in the past. And the way that this virus, SARS-CoV-2, how it does this is that there is this mRNA genome which is inside of the virus. And so when the virus binds with the cell internalizes the envelope, but it also internalizes the messenger RNA inside the cell. Now, if we were to blow this up and show you what happens inside, it would look something like this. Here's the cell with the nucleus. In the nucleus, you have DNA. And that DNA is converted into RNA. And these are made up of nucleotides. Well, that RNA is converted into messenger RNA, and it's exported out of the nucleus into the cytoplasm, where you then have something called messenger RNA, which is still in the same language as the DNA is. But now you've got mRNA. And mRNA is a very specific structure. It has something we call a 5' cap. It has information, and then it has a non-transcribed region at the end with a poly-A tail. And this is what allows you to make proteins, because this messenger RNA is translated by something called ribosomes into protein. And it's this protein that can turn into just about any type of protein you want, depending on the instructions here in the mRNA. Now, as we talked about before, when SARS-CoV-2 infects the cells, it causes the machinery in the cell to make proteins for more viruses. And so it's making more spike proteins, it's making more proteins that go on its surface, it's making a whole bunch of other things that go into making more SARS-CoV-2 virus. And of course, these proteins here can be incorporated into the cell membrane, or they can be exported to outside the cell. So this sort of brings us to why Pfizer and BioNTech are teaming up. It's because the German company BioNTech has perfected, or at least significantly advanced, the technology of infecting with messenger RNA. And so how this new vaccine is going to work is they have a way of making messenger RNA, but delivering it to the cells in a lipid membrane. Now, if you imagine a micelle, or a lipid bilayer, in which the mRNA is enclosed into, so it's well protected, these very small particles can then fuse with these cells, and then what happens is the messenger RNA that they have engineered goes into the cells here, and that engineered messenger RNA will then create a protein that they have genetically engineered. And in this case, that protein is a version, if you will, of the spike protein. But it's a version that is slightly different in that it holds the position of what it looks like when it is docked outside the SARS-CoV-2 virus, not after it binds and is internalized into the cell. So that the final product of this messenger RNA, after it goes into your cells, and after your cells take their messenger RNA and make the protein that they want your cells to make, it's going to make a protein inside of your body that is going to be immunogenic and cause you to form antibodies against this spike protein. And here's what it looks like. This is a publication that was published on bioRxiv, and we'll give you the link to it in the description below. But you can see here that this is the messenger RNA that they've constructed. Here's the 5' cap analog. Here are the coding sites for the receptor binding domain. That's where the spike protein binds to the ACE2 receptor. And here's S1, S2. These are portions of the spike protein. And then you can see here's the non or untranslated region. And then finally the poly-A tail. These additions to the messenger RNA allow it to escape destruction in the cytoplasm of the native cells. So in other words, it preserves it so that it gets translated into the protein. And here's a picture of the protein here down below that your body makes from the instructions from this vaccine. It's a very immunogenic structure that causes antibodies to be made. Now, last month, in the New England Journal of Medicine, they published an article called Safety and Immunogenicity of 2 RNA-based COVID-19 vaccine candidates. And these are the 2 candidates that were put forth by Pfizer and BioNTech. And they wanted to see basically how these 2 candidates did to see which ones would go on to the phase 2 and phase 3 trials. So let's take a look at these, because one of the big questions that we're going to have when we take a vaccine is, how safe is this vaccine? And while we're not going to get a full picture early on, because a lot of the data takes months and months to come out, we can certainly see up front what type of a profile these vaccines have. And you should know what the names of these 2 candidates are. The first one is BNT162b1, and the second one is BNT162b2. So we'll call this number 1 and number 2. And basically what they found was, while they were not looking for efficacy, they were looking for safety, they found that the second vaccine, number 2, was associated with a lower incidence and severity of systemic reactions. So the first thing we're going to do is look at some of the side effects, and we're going to look at both vaccines, both 1 and 2, and we're going to look at the older population and the younger population. So first, let's look at the younger population, 18 to 55 years of age. That's what we're seeing here on this graph. And the 2 graphs up top are vaccine number 1, and the one here on the bottom is vaccine number 2. And just at first blush, you can see here that vaccine number 2 seems to have less in terms of side effects. Now, the other thing that I should mention is that they are looking at making this a 2-step vaccine process, with the first vaccine being given and then the second one being given on day 21, or 3 weeks later. Interestingly, also, this vaccine would have to be refrigerated in very tightly controlled refrigerators. And so here the first column is the first dose, and the second column is the second dose. So let's take a look here at vaccine number 2. You can see here that at least 60 to 70 to even 80 or 90% of these patients had some sort of pain at the injection site. That's not too unreasonable. But in terms of redness, swelling, either on the first dose or the second dose of the second vaccine, that it doesn't look like there was a lot in terms of side effects. It seems as though the 30 microgram dose gave the most in terms of side effects. If we look in the older population, 65 to 85, once again, in the vaccine number 2, there seem to be less side effects than in vaccine number 1. And once again, the biggest problem was pain at the injection site, but in terms of redness and swelling, we didn't see much there. What about more systemic effects? These are the kind of side effects that we're actually looking for a little bit more carefully. Once again, let's look at the second vaccine that was being developed. That's B2 here on the bottom 2. Fever, fatigue, chills, both in the first dose and in the second dose, were much less than that in the first vaccine that was being developed. And that dose 2 seemed to give higher side effects.
Yo, Dick, what's up, Dick? How you doing, man?
The biggest one in terms of incidence was fatigue.
How you doing, buddy?
In both the first dose and in the second dose.
God, I'm rusty with sticks again.
70%.
What's up, man? How you doing?
If you look at participants in the 65 to 85 years of age group, you can see how the second vaccine, or
Welcome,
B2,
Dick.
had far fewer side effects than B1. So you can see the conclusions that the authors came to. They said the safety and the immunogenicity data from this United States phase 1 trial added to earlier safety and immunogenicity data support
you know,
the selection of B2.
It's good, dude. It makes me accountable. It makes me do the reps and everything, you know?
Safety and
It's
efficacy
good to talk to you, too, you know?
And that's exactly what they did. A press release about the preliminary
Every time I feel anxiety, I just
about 5 days
try to lift
ago.
some weights.
And they had enrolled 43,538 participants in this randomized blinded trial.
That's great.
And so what they decided is they did some calculations, and they figured that when they had heard that 94 confirmed cases had occurred, they were going to take a peek at the data to see how it looked. What they were looking for was to see how many of these patients who got COVID had gotten the placebo versus had gotten the actual vaccine.
What's up, Dick?
And what they were able to
Yeah,
conclude
man.
based on the
Welcome, man.
data
Thanks
from
for
those
you.
first 94 confirmed cases of COVID-19 was that the vaccine B2 was found to be more than 90% effective in preventing COVID-19 in participants without evidence of prior SARS-CoV-2 infection in this analysis. And what they're actually asking for now is to continue the study to go up to 164 confirmed cases to see if this holds up and if there are other data points that can be made. That's important because if they were not to do that, if they were to end the study, it would be considered unethical to randomize someone to a placebo given the fact that the vaccine is so effective at preventing COVID-19, a potentially deadly disease. And here is the press release announcing these preliminary results. We don't have this in a peer-reviewed publication as yet, but I'm sure it's coming.
Dick.
You know, in terms of what's actually going on biochemically inside these people who get this vaccine is very interesting. And there are some hints, because if we look at some earlier trials with this very same vaccine in monkeys and in mice, we see some very interesting things. And this was a paper that was published in Medical Archive, which we will put in the description below in terms of the links.
But plank it all, I removed it. I removed it from my regimen, man.
Trials that we just reported
I used to, and then it just hurt my back too much. I'm like, it's like there's no, I feel like I don't.
And so they say
I do leg raises mainly.
The
planks I didn't feel very good in my back. I think I was compensating for something. I think I was doing something wrong and I was compensating with my lower back or something.
Which is what you want. You want it to look exactly as it does.
How about you, man? Do you do planks?
So what they found was
it's
that
not with your back,
these
but he has your back
neutralizing geometric titers were 10 to 18 times that of the SARS-CoV-2 convalescent human serum panel. And not only that, but this very same vaccine that they gave in humans later on, when they gave it to macaques and to mice, they found that their Th1 type CD4 positive and interferon gamma positive response was elevated, and a CD8 positive T cell response was also activated. And all of this points toward a wide and diverse immune response. And one has to figure whether or not this is the reason why it seems, at least on preliminary data, that this vaccine is 90% effective. So let's talk a little bit about the vaccine.
I do
Here you can
V-sits
see
for abs.
these lipid nanoparticles
V-sits? Oh wow,
that
that's crazy,
contain
man.
the
Used to do
messenger
planks,
RNA with the code in it.
I imagine because of your
So
back.
if we look at what
V-sits,
we have
that's
here
crazy.
with the vaccine from Pfizer-BioNTech, they say it's effective at preventing COVID-19 at around
I rode
90%.
like a day or two ago, and
Now,
I think it worked on my arms more than I thought. Starting to feel it here and here in my arms. I'm not going to do many more
so at 28 days
bench
after
press. I
the
might even
first
just do one more set of bench
dose,
press, to be honest.
Study subjects were asked to contact the
Because
site
I'm
coordinator
feeling in my
if
arms.
the patients
I
had
did
any
4
symptoms
already.
of COVID-19.
That'd be good.
And
Ended on
if
5.
after
That's not too bad.
evaluation it was likely that
I'm
they
gonna do more
had
bicycles, more
COVID-19,
flies, but
these
honestly, I'm gonna
subjects
see
were
how my
given
arms
a
feel.
COVID-19 test.
I'll probably do the
The
exercise like
study
my right
was
exercise
interrupted
do some
when the
cardio.
number of subjects with COVID-19 positive test results reached 94. When this happened,
Let's see a
they
V-sit? Oh my
unblinded the
God.
94 so they could see who did and who did not get the vaccine. It was at that time that they
with
released
hands or no hands?
preliminary results
I'm gonna see how I do.
showing that the vaccine was about 90% effective. So some interesting points about that is that really there are no asymptomatic subjects in this result cohort. We don't know what this does to asymptomatic patients. And furthermore, we don't know how long this effect lasts either.
Nice,
So
thanks,
those
man.
will be questions that have to be answered down the line. Of note, the Data Monitoring Committee reported that there was no serious safety concerns. The other question is, does it stop infection? That's
just do those
important
for abs or
because
strong enough.
this
Thanks, man.
vaccine may be just
Thanks, dude.
important
How do you,
in the
what about
individual
your
that
hands?
gets it at preventing them from getting the disease COVID-19. But the question is, does it actually stop infection with SARS-CoV-2? That's important because if it doesn't stop infection, then you can still infect people with the virus, and it can still multiply exponentially. But if it has a sterilizing
Send my hands
effect,
out over my legs.
then it's potentially possible that you could block the spread of the disease. That is
That's
still
hard. I feel my
up
quads.
in the air and a question
Feeling
at
my
this point.
quads.
Now, a couple of numbers that you should know.
Wow,
Pfizer
that's cool, man.
believes that they should have
Okay, I'll
about
add that. I'll add it to my regimen. Here we go.
doses
Here we go, man.
by the end of the year.
V6.
And they're working right now to try to get emergency use authorization.
Yes, here we go.
They also say that they should have about 1.3 billion doses
here we go.
by next year. You need to realize that there are 2 doses. Both doses need to be refrigerated in special refrigerators that keep them at negative 70 degrees centigrade. And the question is how much is this all going to cost? Well, they're saying that per injection, the cost will be about $19.50. But there has been some reports that they are working with the U.S. government, and for those in the United States, it should work out to be free. Now, also remember this, too, is that apparently Pfizer did not take any government money in the production of this vaccine. And furthermore, Pfizer is looking at producing this vaccine worldwide. So this vaccine does have some promise. I would be very interested to hear what you all have to say about this vaccine. It's one of 4 of the vaccines that we're going to do a deep dive and look into. I think this one is interesting because of its novel approach using messenger RNA. Of course, there's another vaccine candidate that is doing that as well.
You want that burn as long as it's not sharp pain.
And that's, of course, the Moderna candidate, which we'll talk about coming up next.
I feel it in my back, too.
Keep in mind that no mRNA-based vaccine has been approved by the FDA. But this particular candidate is interesting because we have the preliminary safety data in, and it looks as though we have the preliminary results of a report about the efficacy data. Of course, more of that is to come when it gets published. And so people can start to make a decision about if this vaccine becomes available and gets emergency use authorization, and when it becomes available, if they would decide to get this vaccination. And don't forget to visit us at medcram.com for continuing medical education. Thanks for joining us.
Oh, that burns. It's nice though, I like it. When you master those, you can go for these. Oh my god. Oh my god. Tux VS's? Elevated versus V6? Elevated? What do you mean? Like Dragon Ball Z elevated? Like, what are you talking about? Elevated. Welcome to another COVID-19 update.
Link. And we talked about the Pfizer-BioNTech vaccine last time. This time we're going to talk about the Moderna vaccine. Cases are still going up in the United States.
Crazy.
And the daily deaths are increasing in the United States as well. And in terms of total cases per million population,
okay, I can try that. I have a bench here. I have a bench right here.
North Dakota, South Dakota, and Iowa.
I'll try with the bench.
So if there ever was a time to get a vaccine out, now is the time. So let's talk about this new Moderna mRNA vaccine and some of the recent results that have come out.
I can't even.
We talked about the Pfizer.
I probably need to.
I need
what you said.
Just sort of put up some notables
I have the dumbbells here,
that
but
vaccine, so we can compare it to the Moderna vaccine. So one thing that's notable is that at 25 degrees Fahrenheit, the Moderna vaccine can actually last up to 1 month. But at that same temperature, at 25 degrees Fahrenheit, which of course is below freezing, the Pfizer-BioNTech vaccine lasts for only about 5 days. However, if you cool the Pfizer-BioNTech vaccine down to negative 94 degrees Fahrenheit, it can actually be stored for up to 6 months. Of course, it's difficult to get those type of refrigeration units. They are working on that. So the other difference that we see between these 2 vaccines is whereas the Pfizer-BioNTech vaccine is on day 1 and then another injection on day 22, the Moderna vaccine is on day 1 and it's a little bit later. It's actually on day 29. So it's an additional week. And when they asked the participants to let them know after which date they developed symptoms, in the Pfizer-BioNTech vaccine, it was 7 days. after the last injection, whereas in the Moderna, it was 14 days.
Oh, I'm feeling pretty good.
Now, as you recall, the Pfizer-BioNTech
just hurts on some
vaccine
weird angles.
results, and these were preliminary results that were released by the company, and we haven't gotten the peer-reviewed data on this as yet, but they said, and they quoted, about a 90% effective rate. And recently we also got
like working
data
out or just
being
like your
reported by
regular
Moderna,
everyday
again, not
life too?
peer-reviewed, not published as yet, but they're claiming a 94.5% effective rate. And while we haven't gotten a lot of detailed information from Pfizer-BioNTech, we actually have gotten some granular data from Moderna. Let's talk about that at this point. So in the study, there was about 30,000 people. And just like the Pfizer-BioNTech study, there was racial diversity to the effect that there was around 11,000 people from communities of color. In addition to that, there was also 7,000 subjects that were 65 years and older, and there were 5,000 subjects that were less than the age of 65 that had comorbidities. And so what they did is they enrolled 30,000 subjects, and of course half of these got placebo and half of these got the 1-2 injection of the vaccine. And let's remind people again that this vaccine works in a very similar fashion as does the Pfizer-BioNTech vaccine, in that it is a mRNA vaccine, which means that this mRNA, which is encapsulated in a lipid bilayer, is injected into the body. It merges with
if I lay down a
specific
certain way.
cells, and
Recommend you do the
messenger
stretches
RNA
I
is
showed you last
released
time, because it
into
sounds
the
like your disc is how
cytoplasm,
mine
not the
was.
nucleus.
A few years
And
ago,
while
before it
is there
got
in the
bad. Oh my
cytoplasm,
god.
it will interact with
Holy
ribosomes,
jeez, dude.
and the mRNA will be translated into proteins. And it's these proteins that are immunogenic.
For sure, man.
and will
I really am
antibodies
taking
to
care of
form,
it. I'm not
well
doing
as
exercises
other
that hurt it or whatever.
immunogenic responses,
You know
such
what I mean?
as a T-cell response, etc. So when they
Yeah, man, definitely listen to you,
randomized
homie.
these
I'm gonna-
30,000 subjects
Yeah, I have
to
the- I
either
have all the
the
images.
vaccine or
Hurt
placebo,
when I
they did
plank.
it on day
Yeah,
number 1,
me too.
they
That's
did
why
it
I
on day
stopped
number
doing that.
29, and they waited the 14 days and then asked them to
Dang.
call in if they
Sharp
had
pain in one
symptoms of
location.
COVID-19. Again, we're looking
Yeah,
for
same,
the
I mean.
actual disease pattern of COVID-19. It was at that point that they were tested,
My disc
and
slipping,
what they did
Jesus
was they
Christ.
waited for 95 people to become
Sorry to hear, man.
positive with COVID-19.
I'm really sorry to hear
Now,
that.
that may sound like a small amount, but remember, if the overall infection rate in a population is about 1%, then it's not unreasonable to believe that in 30,000 people, that only about 300 people would actually become infected. So that 95 is a good place to do the interim analysis. So at this point, when they got the 95 subjects, the data monitoring board unblinded their side to see which patients got the placebo and which ones got the vaccine, so they could make a determination about the efficacy. This is an independent data monitoring board, and of course this is not under the control of Moderna. Well, what they found when they looked at those 95 cases is that, in fact, 90 of those got the placebo, and only 5 of those got the actual vaccine. What is even more interesting, and what we don't have data from the Pfizer-BioNTech people, is that they actually had no severe cases in their cohort, whereas in the Moderna cohort, they did have severe cases, but all 11 of those severe cases were in the placebo group. So this is encouraging news, because it seems to show that the Moderna vaccine, number one, is 94.5%.
Can you imagine going into an experiment? Don't know if you're gonna have placebo or not, and then getting coronavirus? That would suck. That would suck so much.
In terms of efficacy, but what we do
Get
see
the
here is
placebo
that
and then you
it
get
seems to be
coronavirus.
able to prevent
That's
severe
terrible.
COVID-19.
That is a hero for
What
science.
we don't know for either of these vaccines is whether or not these vaccines actually prevent infection of the virus. Because here the endpoint was looking at symptoms of COVID-19. It would be interesting to see whether or not this vaccine actually causes a sterilization of the infection. And why that would be important is that if in fact this vaccine could actually prevent an infection with SARS-CoV-2, if it was effective at doing that, then you would see a drop in the transmissibility of this virus. It wouldn't be able to spread to other people. Whereas if there was no effect on infectivity and only an effect on preventing the symptoms or COVID-19, then yes, it would drop hospitalizations dramatically. But as we know, asymptomatic transmission of the virus is a big way that the virus is being transmitted currently. And it would be really interesting to know whether or not this vaccine could actually prevent that too. So in terms of safety, looking at both the Pfizer, BioNTech, and the Moderna vaccine candidates, the Data Monitoring Committee has said that they have not seen any serious safety concerns with the Pfizer-BioNTech candidate. And the Data Safety Monitoring Board for Moderna has also said that there was no significant safety concerns. Now, with Pfizer, they have said that they're going to be releasing more specific data on safety in the coming weeks. Now, Moderna has given us a little bit more granular data, and you should look that up. And in looking over the side effects, they were mostly mild to moderate. They were short-lived, and they were the type of side effects that you would expect to see with any kind of vaccine, even a flu vaccine, such as fatigue, myalgias, arthralgias, headache, pain, and redness at the site. So you can see the differences here very clearly. The similarities are also very clear. Both of these vaccines seem to prevent disease very effectively. However, both are still in question about whether or not they prevent infection. In both, you require 2 vaccine shots. In both of these vaccines, there seems to be a good randomization and also representation from communities of color. There also seems to be a lack of severe
Hear about the
side
link between
effects that are
coronavirus
concerning.
population vitamin D?
But
I
of
did,
course,
man.
because they've only been around for a few months, we don't have long-term safety data on either
What
of
I
these
think
vaccines.
about that, though,
And remember, we also don't know
is,
how long
you
this
know,
type of
vitamin
effect
D is
from
such
the
a
vaccine is going to last.
proxy
And
for
of
like
course,
just
the
general
other
health
big
and general
similarity
life health
between
and
these
diet,
two, the Pfizer,
sun,
BioNTech, and the
even
Moderna,
like
is
mineral,
that they are mRNA
just
vaccines. And
vegetables,
as it says here on
you
the
know,
Moderna
a lot of
website,
Americans unfortunately have
mRNA
really
is a
bad diets, really
temporary
sad,
set of instructions
and
for
bad
cells to
lifestyle,
make a
unfortunately,
protein.
and Canadians
And
too.
mRNA is made normally using
And
DNA. But in this case, the
I
vaccine
think I consider more of a
itself
proxy
contains
than
messenger
a
RNA.
cause, I
And that, of
guess.
course, makes the
You know what I mean? There's
proteins,
so many micro
which
and
are the
macronutrients.
source of the immunogenic response
It's hard to
in the
quantify
body and causes
the
a number
effect.
of immune responses, including
Yeah, I think most people were
antibodies.
deficient. Yeah, exactly.
And here is how
And with nutrients, it's so
Moderna
hard to
depicts
identify
its vaccine.
specifically the
As you
effect,
can
right?
see here,
Because
the
it's
messenger
each
RNA
quantity
is packaged,
is
and there is a
is
5'
conditional, right?
region which keeps
There's like
it
macronutrients,
from being broken down
micronutrients,
in the cytoplasm. And
right?
there's
Micro
also
just
a
needs small
3'
amount.
region
So
and a poly-A
just like the
tail here at
variation
the end,
scale,
which
you
also
can't. It's
does
really tough
something
to
similar.
look at one alone.
Next
You
time
know
we're
what I mean?
going to look at the other 2 vaccines that are
Not
coming
because
out,
they
and that
have
includes the one from
like
Johnson &
interaction effects,
Johnson and
which
also
they probably
from
do, but I mean more
AstraZeneca and
specifically
Oxford.
volume.
And those are not
Right, like
messenger
quantity.
RNA vaccines, but
Like
actually something
deficient.
rather different, which we'll take a look at
Deficient
next time.
implies, yeah.
Meanwhile, while all this
Yeah,
is
deficient's
happening
probably
here on the West
a
Coast, we're
good
starting
word
to
for it.
see stricter
That takes that
rules
quantity into
once
account.
again being imposed.
Because
Once
deficient
again,
implies
there is going to be a restriction on indoor
accepted
dining and
level of health
also
and-
religious
and
meetings
unhealth.
inside and gyms, etc. There's also a
Yeah, man. A
travel
lot of unhealthy
restriction.
people, unfortunately, sadly.
As you can see here on Friday, Newsom and the governors of Oregon and Washington
Yeah, it's crazy,
issued
man.
a
I've been taking
travel
vitamin D.
advisory
We're taking little vitamin
urging
D
their
pills.
residents to avoid
It's look like it's sunny
non-essential
here, but it's
travel
like
and
gray,
to
man.
quarantine for 2
It's getting
weeks
really
after
gray outside.
arriving on the West
November,
Coast from
dude.
another
Canada,
state
November.
or country. In Oregon, Governor Kate Brown also
You know how it
announced
is.
a 2-week freeze to limit restaurants to offering only takeout food and close gyms. She said that the travel advisory would become a requirement if cases remain at current levels. And Washington's Governor Jay Inslee has ordered gyms, bowling alleys, movie theaters, museums, and zoos to shut down indoor operations. The reason for limiting these things, of course, is to reduce the incidence of hospitalizations. Which brings us to another interesting article in JAMA Network titled Outcomes for Out-of-Hospital Cardiac Arrest in the United States during the coronavirus disease 2019 pandemic. And this was published on November 14th, 2020. And essentially what they found was that during out-of-hospital cardiac arrest, the return of spontaneous circulation in those patients was 18% lower overall than before the pandemic. They also found that rates of survival to discharge were 17% lower, primarily in communities with moderate to high COVID-19 mortality. And incidence of out-of-hospital cardiac arrest was higher, but largely in communities with high COVID-19 mortality. Here you can see the results that were stratified by county-level coronavirus disease in 2019. And in the overall category, you can see here very clearly that there was 69.7
I've had some pretty awful flus the last few years, man. I had some absolutely terrible flus.
Cardiac arrest per 1 million
And I'm like a
residents.
pretty healthy person, and I eat pretty healthy.
That
And
went up to 88.5.
I imagine if I was a sick person, I'm not saying that I had corona, but I'm saying I don't know what happened last year. I've had terrible flus.
Mortality rate increased.
I haven't had the flu shot in a few years.
So did the difference between 2019 and 2020
like
for the most part.
awful.
And that was all statistically
So imagine
significant.
this virus.
And the two theories behind
totally
this,
different
why
mechanism
this
pathway,
was, in
right?
other words, is
someone
number
unhealthy,
one, many people may have been very concerned about going to the hospital because there were a lot of COVID-19 patients there. And therefore, their disease manifested itself much further.
I got one
and
from
therefore it
Sunset
was
Beach,
much more
Vancouver
difficult
Harbour,
to
on the
convert
May
those
2-4
patients
weekend.
back into a
I went
spontaneous
swimming, and I
rhythm
got so
with
sick.
spontaneous circulation. Therefore, there was a higher out-of-hospital cardiac arrest incidence. But another theory emerged and is detailed in this article, which we'll give you the link to, and that is that a number of the protocols that were initially started on these patients when EMS and first responders would go out, they modified it in a way so that there was perhaps less intervention in favor of protecting the first responders more from developing an infection with SARS-CoV-2. They said in the study, this raises the possibility of whether protocols that were rapidly put into place following the beginning of the pandemic could have influenced patients' likelihood of achieving sustained ROS, or return of spontaneous circulation.
I think I'm going to do
For
one
instance,
more
the US Centers for
bench press
Disease
set
Control and Prevention
to round it
and
off
the
to
American
5,
Heart
and then I'm going to
Association
do probably
each established interim
5 to 10
guidelines
minutes on the
for
exercise
EMS
bike.
and
This is just a
professionals
lunchtime
during
stream.
the pandemic, which
I'm using my
included
lunchtime and my 2
screening
breaks for the
911
stream.
calls for likelihood of COVID-19
So I gotta get back in
infection, limiting the number of EMS
18
personnel
minutes.
during initial response, pausing critical chest
So I'm
compressions
doing one more
during
bench set, and then I'm going to
aerosolizing
ride the bike
procedures
for me
such as
5 minutes.
intubation, limited bag, mask, ventilation, when done without specialized filtration, and not transporting patients to hospitals without ROSC, or return of spontaneous circulation. Many of these recommendations are believed to be essential for protecting frontline healthcare workers from unnecessary exposure in communities severely affected by COVID-19 pandemic, but may also decrease the likelihood of a successful resuscitation. So I thought this was an interesting article because it shows the collateral damage of a pandemic. Tell me what your thoughts are below, and thank you for joining us. Don't forget to check us out on medcram.com.
Woo! That felt good. I love ending a workout on like a good last rep set. Oh, and I'm gonna ride the bike. I might do another bench set after, but I'm gonna ride the
So
bike.
when we decided on COVID-19 as a subject for this webcast, the first person that came
What is this video? I'm gonna have to change the video, I think.
to mind as a speaker was Roger Schwelt, co-founder of medcram.com. Medcram.com is a leader in producing instructional videos
I have to
for
give
medical
credit to whoever
professionals
gave
and
that.
schools.
Yeah,
They
yeah.
provided videos to a variety of medical schools, hospitals, universities, and
Let's
their
see, let's
YouTube
go
channel
back,
has
let's go
received
back.
over 50 million video.
I don't know. I gotta write this guy's name in the chat because they gave two great videos.
Welcome to another
Medcram. Medcram on YouTube. Check them out. Okay, now let's look up another video. And then, while I ride my bike. Coronavirus, mRNA, vaccine. Oh my gosh. CNBC? Should we watch the CNBC one? Nah. 6 days ago? How long is this? 11 minutes? That's good.
Exciting vaccine news. On November 9th, 2020, Pfizer released data saying that their COVID-19 vaccine has so far shown 90% efficacy in preventing disease in their clinical trials, which is amazing. It's not the end of the road, but it's a new kind of vaccine called an RNA vaccine, which I am super excited to talk about. So let's do that right now. But I do want to throw a disclaimer on this video. I am not a virologist or an immunologist or an epidemiologist, but I am a geneticist, and my thesis was focused on RNA silencing and sequencing. So I do have a lot of experience thinking pretty deeply about RNA and how it works. And that's why I'm really, really excited to talk about this story in particular. So let's start really big picture. There are a lot of different companies right now trying to create vaccines against COVID-19. The whole idea behind a vaccine is that you expose someone to a dead or weakened form of a pathogen, or to just a part of that pathogen, so that their immune system can learn what it is and how to fight it without actually having to contract the disease. And once you have a high enough level of the population vaccinated, you can slow down the spread of the disease through herd immunity or community immunity. Now, I created an hour-long webinar on vaccines with Mini PCR Bio that you can check out in the card above or the description below if you want a really deep dive into the history of vaccines, how they work, and the many different strategies that companies are taking right now to create COVID-19 vaccines. So you can watch the full thing over on their channel. But briefly, different companies are taking different strategies right now. Some are using traditional strategies like dead versions of the virus to create vaccines. Others are using different harmless viruses to deliver nucleic acids or proteins from the virus that causes COVID-19 to people. But today, we're going to talk about RNA vaccines. RNA is a really important molecule in your body. Over the years, we've learned that RNA plays lots of jobs in our body and in our cells, but one of the most important jobs is to carry the instructions for making proteins from the DNA in our nucleus out into the rest of the cell where proteins are made. So genes in our DNA are transcribed into mRNA or messenger RNA, which is then translated into protein. And this holds true for pretty much every living thing on Earth. Now, many viruses also have DNA genomes, but some, like SARS-CoV-2, the virus that causes COVID-19, have an RNA genome instead of a DNA genome. But in the same way, the RNA encodes proteins which help build things like the outer shell of the virus and something called a spike protein. But the virus can't replicate on its own. It needs to hijack some of the replication machinery inside our own cells first, before it can make copies of its RNA and the proteins that it needs to build more virus. If you've seen pictures or drawings of SARS-CoV-2, you'll likely recognize this spike protein. It's what binds to receptors on our cells, causing the cells to let the virus in. And it's been the potential target for many of the vaccines currently being developed. The idea is that if we can show your body the spike protein and allow it to create antibodies against it, your body will be primed to fight and recognize the full virus covered in those spike proteins if you get infected. And we can do this in different ways. So again, we can produce a different harmless virus that's covered in these spike proteins and give that to people as a vaccine, or we can produce just the proteins themselves and give those to people. But an mRNA vaccine works differently. It delivers just the RNA message of how to build that protein to your cells. Then your own cells do the work of producing that protein, displaying it on their cell surface, and then developing an immune response to it. And this is really cool. It's using your own body to make the functional part of the vaccine. That's just like really cool and really smart to me. It also has a number of technical advantages.
Really messed me up.
So it's way
Not messed me
cheaper
up,
and
but
easier to make a lot of
worked on
RNA
my
for
legs more
vaccines
than
it is to have to grow and then kill lots of the virus, or to build a new virus, or to create lots and lots of the single protein in the lab. It was also way easier for scientists to get started designing this and working on it because they didn't actually need to get a sample of the virus to get started. They just needed a text file of the virus's genome. Vaccine development typically takes 3 to 5 to 10 years. It's a long process. But this
Before
one has gone
streaming
from
workout
start
again?
to near finish in under a single year, in part due to how easy it is to just make lots of RNA. Another advantage to an RNA vaccine is that if we do
Oh,
need to
my
change the
knees.
vaccine slightly in the future due to
rowing
mutations in
machine, man.
SARS-CoV-2, it's just much easier to change and produce an RNA code than it is to grow a bunch of new virus or to make
That was
new
a good. That was a
proteins.
good workout.
RNA vaccines can be delivered via a
Yo,
needle, just like other
Zamorabis.
vaccines we're used to, which is good. And you can try and do
PVC,
an
Hilanis.
injection of just mRNA,
I
but
don't
you
know
can
about you,
sometimes
but I
run
don't
into
have the balls
problems
to
with
use a
enzymes in your
vaccine.
body starting to break it
Oh,
down
for
before it
sure,
does
I'm
the work
definitely
you want
gonna-
it to. So many of
I'm
the
just
vaccines
looking
currently
at
in
information,
development
man.
are
I'm
trying
not
to
like.
package that
I'm
RNA
definitely not
somehow
like a
into
pro
delivery.
vaccine.
As
I
an
think
example,
vaccines
the
are
Pfizer
good,
vaccine that we're
but
going to
there's
be
a
talking
lot of
about
issues,
today
right?
is packaged into lipid
A lot of effing
nanoparticles.
issues.
You can probably figure out what that is. Nano for small, lipid for
First
fat,
one
and
being,
particles for particles.
depending on
so the RNA is
what type
basically
of
packaged
formulation,
into
what type of
tiny fat
preservative
particles
they
that
use. A
can
lot
more
of
easily slip inside your cells.
the flu
There are
vaccines.
potential drawbacks to RNA vaccines, but we'll get to
Let's
those in just
pause.
a minute. Research on mRNA vaccines has
The
been
issue
going
with
on.
the issue with RNA vaccine, okay, specifically RNA vaccines issues are there's always a risk of prions. I'll let everyone else use it first, yeah. But like for example, mad cow disease. That's it was the formulation of prions due to cows eating other cows' brains specifically, and there was no mechanism in science before this event of the creation of the bovine prion, the mad cow brain, encephalo. I forget the name. Basically, turns the brain to mush. And scientists had no idea that it was going to happen like that, and it happened. And they are raising a lot of vaccines on bovine serum albumin, which is bovine protein. And there is always a risk that there are prions inside of these vaccines that have been created. They are sterilized, sometimes with formaldehyde, sometimes with UV, sometimes with mercury, right? And the GSK, the multi-dose flu vaccine, the quadrivalent, it has like 50 parts per million of mercury in it. Yeah, it's an extremely high amount of mercury, and they don't tell people. And it was in the GlaxoSmithKline 2018-2019 formulations of the flu vaccine, and that's one of the main arguments of why it may potentially cause autism, because mercury is a very strong neurotransmitter interrupter and affects the nerve pathways, because it's a very strong heavy metal, right? It just attracts all the electrons and everything around. So the beginning of a zombie apocalypse, yeah, exactly. So those are the two main things: the prions in bovine serum albumin and the 50 parts per million of mercury that GlaxoSmithKline puts in their vaccines because they're lazy. And that's why I'm like, no, you know what? I do take vaccines, but you got to make sure that the preservatives are correct, and you got to make sure that they actually correctly sterilize the vaccine, not using some sort of like, let's look at the consequences after that happened with like mad cow disease. You know what I mean? Like freaking Malcolm from like Jurassic Park. Like nature finds a way. That's like me. Like that's like you. Sounds like too. I'll be vaccinated in 5 years exactly. You know, nature will find a way. It's exactly what happened, right? Daniel Creighton or whatever, Creighton, the use of the frog DNA, changing sex so that they can reproduce in Jurassic Park. It's the exact same thing, man. on that analogy that I just made. Yeah, exactly. Oh, for sure. Well, the first thing is I'm not entirely convinced that the coronavirus exists. I've just received all my information from everyone else, right? I'm not denying that it probably does exist. If you go on the Blastex on the website, you can actually get the guanine, thyrosine, adenine, and cytosine DNA sequence pair for it, and the protein, right? Blastex and Blast and Blastex. Those are the DNA and RNA databases, and they have specific. I'm sure if you go there, they'll be like, click here for the COVID sequences, whatever. You know, it's all publicly available. That's what's great about it. And you can actually Google it. You can like Google a base pair sequence and see what it's similar to, right? That's how they were able to determine that this is possibly new, or that it's different from the previous ones, you know. Yeah, man. Yeah, I'm gonna wait for sure. I'm gonna wait for to see how people turn out. You gotta look at the product monograph too, right? That's what I do. That's what I do in my job, man. That's why I learned. That's how I learned about the mercury, man. I looked at the product monographs of the vaccines because you gotta make sure it's not live. Gotta make sure it's not a live vaccine. Gotta make sure it's just like parts of it is actually successfully deactivated, you know, or killed or whatever. So I'm waiting for that product monograph and see where like it gives all the information what it's raised on. Because that was the issue, right? That was the issue with there's a very strong theory that HIV and AIDS may have been raised in, but or may have been distributed in a polio vaccine in Africa that was raised on the livers of chimpanzees in the 60s that had very ill symptoms in the United States. And because they were growing it on the liver, like directly on the liver of the poor phenotype chimpanzee, and due to the very rapid what's it called, expansion of HIV in Africa during this time, and due to the expansion of the polio vaccine in Africa during this time, and due to the evidence that they did raise them on poor phenotype chimpanzees from Africa that they imported. I think it's very. I don't know the statistics. I haven't done the statistics on it. I haven't looked at statistical reports on spread and the HIV strain, but all those other facts are true. But I haven't done the analysis because I don't have that data. Because I'm not a HIV epidemiologist. I'm just a ranter on Twitch. But yeah, man. Thanks, dude. Thanks, Dick, for listening, man. I gotta sign off. It's gonna be about an hour. My lunch 2 breaks. Hope you're doing well, man. You said you had a business that you have a business of yours that is going pretty well now. That's good, man. I'm hyped for that, dude. I'm happy for you. Okay, what's her name? Alex Dianis. Alex Dianis. Yeah, I want to not work for the man. That's my life goal. Yeah, man, that's such a good life goal, man. I want that life goal too, man. I just wrote that's the name of the video we watched just to pay respect to that, to her and everything. Yeah, man. That's smart. The earlier you plan for it, the better you'll be at achieving it. You know what I mean? It seems like this opportunity right now is the opportunity to do that. Going out in rush hour, come home in rush hour, and somebody I know, man. It's. I know I'm gonna have to reject it. I'm riding this wave until I no longer can, and then I'm gonna see how I feel after. It's gonna be like a game time decision whether I'm gonna do that again or not. I've been really lucky and blessed the way things have turned out, but I don't see this being very sustainable. So I'm planning for the future, right? That's why I'm being very cautious, saving up and everything. So yeah, I'm laying the groundwork during the pandemic. Yeah, man. I'm learning skills. Just learning what's available in terms of like online, like buying or selling, just exchange of money and information and products and goods. Like there's like apps where you can print out printing labels, right, for the transaction. If you're gonna sell stuff to someone, right, you can just like print out all the label information. It's there. You gotta buy the little label printer, but still, if you're gonna mail, if that's what your business is gonna be, shipping goods or whatever, like that exists. Yeah, man, it's crazy. I myself am going into like serious lockdown. You know. Nice, Dick. Congrats, buddy. That's good, dude. That inspires me, man. That's inspiring me to do that professionally. Dude, the rowing machine took a lot more out of me than I thought it did. I realized that this worked out. Holy jeez. Yeah, if you got dreams, go for them, dude. Nice, man. Dick. That's awesome. You only get one life. I don't think I have quotes set up here. Let me see. Add quote. I don't think it's Dick is gone. What was it? Got dreams. Go for him, Jude. Yeah, if you got dreams, go for and do. I don't know if this is gonna work. Aw. I'm such a B grade streamer. I can't even have chat on screen without my computer lagging. I can't have chat on screen anymore. It lags too much. It lags the runs. And you know the firm is gonna have an issue with that. The elite, the firm elite, because they're a bunch of firm guys, good guys. They are a bunch of great guys. Oh my god, man. I'm like, I don't even know what I'm saying anymore. Like, oh, I need to just sign off. Thank you. Thank you, Dick. I gotta go. Thank you, the firm. Thank you, the elite, for putting my stream on your GoldenEye, your GoldenEye page while I lift weights, talking life plans with Dick. Okay, Dick, I do have to sign off though, man. Catch you later, man. I'll probably be playing GoldenEye this weekend, probably. Maybe probably later today, too. Hope you're good, dude. Later, man. Yo, thanks, man. Appreciate it, man. Appreciate it, dude. You're the best. Alright. Thank you. Catch you later. Thanks for the stretches. I will work on them. Thanks for the concern, too. Alright, peace. Nice.